Nowadays, we're using more and more finite products as raw materials for production and energy supply. These products can also be found in, of all places, our rubbish. The Kahlenberg Waste Treatment Association, ZAC for short, has managed to use waste as a resource and to extract the maximum of energy potential and raw material from household waste. Through the use of the innovative maximum yield technology, the association's mechanical biological waste treatment facility works reliably, is self-sufficient in terms of energy use, and has almost no emissions. The end result is that high-quality raw materials and energy sources are generated in the form of economically useful products from over 100,000 tons of waste each year, thereby making an important contribution to the conservation of resources and the prevention of climate change. MYT consists of 5 tried and tested, perfectly synchronized process steps. The first step is the intake of waste. The delivery hall. This is where the waste begins its journey through the MYT facility, and the last point at which it can be plainly seen. The grabber loads 2 conveyor belts equally with the waste that's been delivered and sorts out large impurities and recyclable waste. The checked waste then proceeds in metered quantities to Step 2, mechanical processing. Here, the waste is automatically separated according to material type and differences in size. The concepts and systems used are based on the ZAC's many years of experience and guarantee safe operation and the systematic separation of fuels, minerals, metals, and a small amount of non-recyclable residual waste. The checked and processed waste then proceeds to the third step of the process, the biological stage. In the intensively tested multiple zone reactor, MZR for short, the waste is selectively reduced in size and homogenized using a horizontal agitator. Processed water is added as part of a cycle, thus ensuring appropriate, unchanging consistency. After being in the mixer for a short period of time, presses are used to separate water from solids. A portion of the microbially assimilable organic material is washed out with the resulting press water, then purified several times and used to generate energy. The water treatment. MYT incorporates a practice-proven and mature water treatment process. The processed water from the biological stages is mechanically and physically processed to separate coarse and fibrous materials. Microorganisms living in biogas fermenters create biogas from organic compounds. This biogas is then used in the nearby cogeneration unit to generate electricity and hot water for the local district heating network. In the process, more electricity and heat is produced every year than the entire mechanical biological waste treatment facility itself needs. At the end of the water treatment process, purified water, water for agricultural irrigation purposes, or nutrient-rich liquid fertilizer are all available. In addition to water management, the ZAC also sets new standards in exhaust air purification. Biofilters are containers filled with natural substances, such as bark mulch. The microorganisms in the biofilter reside on the biofilter material. The air-polluting substances in the exhaust gases are absorbed by the microorganisms and are then broken down biologically into carbon dioxide and water vapor. Step 4. Biological drying. After the separation of water from solid just completed, some microbially assimilable organic material remains in the solid material, thereby allowing a biological drying to take place that is both energy-saving and economical. In tightly sealed concrete tunnels, air passes steadily through the waste, providing the microorganisms with oxygen. These microorganisms feed on the material's organic components and produce heat energy for drying. After a brief treatment period, the homogeneous dry and fine solid material is available, which can subsequently be easily broken down into its constituent components. Step 5. Mechanical material separation. Screening and sifting systems then break down the material from the biological drying process into different fractions. Energy-rich combustible materials, as well as minerals, are transported through special conveying systems to the loading stations and can be dispatched without requiring any further treatment. The goal has, at this step, been achieved. Economically utilizable raw materials and high-quality energy sources have been obtained from waste material in industrial processes, which can be used to replace fossil fuels like coal and crude oil. What happens to the high-quality RDF created by the MYT? The energy-rich substitute fuels can then be used in industrial coal-fired power stations to generate electrical and thermal energy. In the nearby combined heat and power plant in Pforzheim, Germany, up to 20,000 tons of hard coal, or about a quarter of the plant's requirements, could be replaced by substitute fuels, which equals approximately 5 megawatts. Another customer for the substitute fuel produced is a regional paper manufacturer. At the truck docking station, the material is then transported via screw conveyors and conveyor chains to an intermediate silo. From there, the RDF is transported pneumatically and blown into the combustion chamber of the circulating fluidized bed boiler. The household waste sourced RDF substitutes imported natural gas, oil, or coal. In a rotary kiln of a major cement manufacturer, the RDF produced by the MYT plant is burned at high temperatures between 1500 and 2000 degrees Celsius at the main flame, thus achieving complete destruction of organic matter. The residence time of the fuel in the furnace is longer than 2 seconds, and therefore in full compliance with current legislation. A neutralization of the acidic gases of the fuel is achieved by passing the gases on over quicklime in the kiln. Emissions at the chimney are continuously monitored by devices connected to a computer system and are communicated quarterly to the appropriate environmental control agency. The fuels produced from waste conserve resources and reduce carbon dioxide emissions, which is good news for the environment. The products created by the MYT process clearly illustrate the great potential that exists to create energy and raw materials from household waste with minimum impact on the environment. In addition, dependence on oil, gas, and coal imports is minimized, and a positive contribution is made in the effort to prevent climate change. See for yourself by visiting the ZAC in Ringsheim. MYT can be seen up close by the people and is waiting to be explored and marveled at. The facility is situated amidst nature, where not only goats and donkeys can be found in the vivarium, but also where rare and endangered plant and animal species can be seen. Located in harmony with nature and accessible to the public since 2006, something has been achieved here that lots of people would still consider to be a pipe dream: the generation of energy and raw material potential from household waste.